Alright, so today we're going to be doing LeetCode question 160, which is intersection of two linked lists. So what this question basically gives you is you're given the head of two nodes, right? Or the head of two linked lists. Um, Most of the time they're going to be of different sizes. Sometimes they can be the same. The code we're about to do is universal and works for both types of questions. Um, but what we're doing right now is, given these heads, we need to iterate through each list and find the value where they meet up. So in this example, you could see that they meet up at C1, right? So we need to return C1. So how are we going to go and do this? Well, first things first is usually when working with linked lists, you know that you're going to have to kind of use a while loop, right? That's how this stuff kind of works. So given these heads, the first thought of mine, or the first thought that comes to my mind is, okay, like let's go and make some dummy variables for these so we can start iterating. So I'm gonna make some dummy variables, right? And I will make head A underscore node and head B underscore node, right? And I'm just gonna set this to head A. I'm gonna set this to head B, and there you go, right? And now with these variables, we're going to create a while loop, right? So while head A underscore node does not equal head B underscore node, right? So what this is, what's happening right now is while head A doesn't equal head B, right? This is important because we're trying to find when they do equal one another. So when we set up this condition, it allows us to basically continue looping and doing what needs to be done in order to get that, right? So once it stops, we should just return whatever we have, because once it equals one another, then that's our answer, right? Um, so what we're going to do is we are going to create an if statement, right? So this if statement's basically, this if statement is going to say, okay, if the value that we're on currently right now does not equal none, then do this. So if head A underscore node, right? So if the value we're on does not equal none, then I'm going to want to do head A underscore node equals head A underscore node dot next, right? So this is just simply, okay, if we're not equal to none right now, iterate to the next, right? Else, what we're going to do is, if it is equal to none, then we're going to want to send or set head A underscore node equal to head B. So what's happening is we're starting at, let's say, A, right? A is going to iterate through the entirety of this list. Once we reach C3, right, we're going to go and bring A to the beginning of B, which will be B1. And the same thing goes for B, right? So once B goes B1, B2, B3, C1, C2, C3, it's going to go to A, right? This is sort of kind of like Floyd's algorithm in a way, right? Not necessarily, but basically the whole premise of the problem is once you reach the end of a linked list for, let's say, head A, switch it to head B. And once head B reaches all the way to the end, switch head B to head A, right? And this switching is going to get them every iteration closer and closer to one another until basically they reach the same point. So if this if statement is for head A, and I just told you what we got to do for head B, it's going to be the same exact thing. So I'm literally going to just copy and paste this and do a couple of changes. So head B underscore node. If head B underscore node equals head, well, if head B underscore node, the head B underscore node equals head B dot next, else head B is going to equal to head A. So this is head B, and it's going to turn into head A, right? And head A turn into head B, right? It's a little bit confusing, but don't you worry, because I'm literally about to show an example, right? And once this is done, right? Remember, because the while loop is just saying, well, it's not equal to one another. So once it does, all we need to do is just return a head, which in this instance we'll just return head A. Oh, head A underscore node, right? Beautiful. So how is this going to look? So this is literally the example we have on the screen. So you have A1, A2, C1, C2, and C3, right? A1, A2, C1, C2, C3, and then null. Um, you don't necessarily see the null, but it's right after there. It's nothing crazy. And then you have B1, B2, B3, right? B1, B2, B3, and then the rest, and then null, right? So looking at the code that we've written, right? Let's start. If head A underscore node, right? So if it's not equal to none, just do next. So these two are going to be moving simultaneously, right? For the majority of this code. So, everything's going well, everything's going well. Node A equals null, and then node B comes here, right? And now we're on to the next, right? So once we get here, what's going to happen is list A and B are going to switch, right? So I know it seems confusing, but once we stop here at node A is going to move over here, right? And node B now equals a null. So if we just move node A, right? If we just move node A, then we have to move node B because now it's here. So it's going to be just like this, right? And this is kind of where we leave off once we can start, going at the same pace again. And you kind of visually see that they're going to meet up. Um, the reason why is because we did we did a switch, right? So node A is at list B now, and node B is at list A. And because of the different lengths, and not even because of the different lengths, but just because of Floyd's algorithm, they ultimately will meet up, right? So now we can continue going, right? So if head A underscore node, right, there's obviously space for these two. So move this, move this, move this, move this. And then we stop here because we're looking at the while loop and it says, well, head A underscore node does not equal head B underscore node, right? Well, these two equal one another now, right? So because of that, then all we got to do is return head A, and we return head A or head B, it doesn't matter, either or. They're going to equal one another, and we just return it, and that should be our answer. So given this code, if I click run, we should get an accepted.